Okay, multiplying polynomials. So a little bit of a warm-up first. Evaluate f of x equals 4x to the fifth minus 3x to the fourth plus x squared minus 5. So what we're going to do is we're going to take 2 and plug it in for x in each spot. Okay? So it's going to look like this. 4 times 2 to the fifth minus 3 times 2 to the fourth plus 2 squared minus 5. So first thing you want to do, please excuse my dear Aunt Sally, always remember to evaluate your exponents. So 2 to the fifth is 2 times 2 is 4, 8, 16, 32. So this is 4 times 32 minus 3 times 2 to the fourth. 2 to the fourth is 16. Plus 2 to the squared, which is 4, minus 5. So 4 times 32 is 128 minus 48 plus 4 minus 5. And last step is to combine them all. So 128 minus 48 plus 4 minus 5 is final answer of 79. Similar idea, an application problem. So in this little story problem, we have the weight of an ideal round cut diamond can be modeled by this crazy decimal model. And since where W is the weight of the diamond and D is the diameter. So what if you have a diameter 12? Okay, so what we're going to do is there's two ways to do this. You can physically take this 12 and plug it in here, here, and here. So cube 12, then multiply by 0.00583. Square 12, multiply by negative 0.0125, and so forth. The other way, the quicker way, is just, again, use our handy-dandy calculator. Go to y equals, and enter in 0.00583, and put x, and we're going to cube it, so to the third power, x cubed, minus 0.0125. Oops, this one. Still missing. 1, 2, 5. And then x squared plus 0.002 2x minus 0.01. And then just go to your table and scroll down to 12. And there you have it. About 8.5, let's see, carats. That's it. So to multiply polynomials, two polynomials, you multiply each term of the first by each term of the second, then combine like terms. So basically what we're doing is we are distributing. So we're going to multiply 3m squared n times each of these terms. And we do that by dealing with sign, number, variable separately, so as not to get confused. So first off, we're multiplying two positives, we need positive. 3 times 4 is 12. Now we deal with our variables. M squared times m cubed is m negative 1, remember. So that's going to be negative 3. M squared times m squared is m to the 4th. N to the 1 times n to the 1 is n squared. Next, 2 times 7, 21. M squared times m to the 1st is m to the 3rd. N to the 1st times n to the 2 is n to the 3.
And last but not least, you're going to see a little quick flash of this, which is wrong. And it wouldn't let me edit the video anymore to cut that out. So here you go. I drew the line and then somehow originally forgot to distribute it. So plus times a minus, 3 times 5 is 15. The m squared tags along. N to the 1st times n to the 1st is n squared. And now I look for any common terms.
I have M5, N1, M4, N2, M3, N3, and just N. Nothing combined, that's my final answer. Okay, so here we have a binomial times a binomial, 2 by 2. We're going to take the 4x cubed by each term. So 4 times 2 is 8. X cubed times x to the 1 is x to the 4. Second term, 4 times negative 7 is negative 28. X cubed times y is just that, x cubed y. Now we're going to take negative 5y and send it in. Negative 10 xy and plus 35, negative 5 times negative 7, y squared. So once again, in this case, we have nothing that we can add together, no like terms. That's our final answer. We'll bring number 3 down here a little bit. This is, remember, this is really 5x minus 3y times 5x minus 3y. If you remember the shortcut, we'll use a shortcut up here. You can square the first term, 25x squared. You can square the last term, plus 9y squared, and then multiply these two and double it. Negative 3 times 5 is negative 15. Double is negative 30, and then just deal with the letters x, y. Otherwise, the long way is multiply each by each. So here we get 25 x squared. We get negative 15 xy. Here we get negative 15 xy. And here we get our plus 9y squared. Once these combine, we end up with this answer up here. Okay, so here we have a 2 by 3, meaning that right off the bat we're going to get 6 terms before we combine anything. So I'm going to multiply each of these by 2x squared and each of these by negative 3x. So 2x squared times x squared is 2x to the 4th. 2x times negative 3x is negative 6x to the 3rd. That's x to the 1. And then plus 2x squared. There's my first 3 terms. Now I'm going to send it to negative 3x. Negative 3x cubed, because this is x to the 1, plus 9x squared minus 3x. Now we look and see if anything will combine. So we have x to the 4th, x to the 3rd, x to the 3rd right there. We have x squared and x squared. So 2x to the 4th, standard form, descending order. Negative 6, negative 3 is negative 9x cubed. 2x squared plus 9x squared is 11x squared. And then just the minus 3x. Final answer. So 2x minus 3 times 2x minus 3 times 2x minus 3. Sorry, 3y. hybrid and do the shortcut right here and go right to 4x squared, 2x times negative 3y is negative 6xy, double it, negative 12xy, and 3y times 3y is 9y squared. That gives me my trinomial. And now I'm going to send in the 2x and the negative 3y. So 2x times 4x squared is 8x cubed. 2x times negative 12xy is negative 24xy. 2x times 9y squared is plus 18xy squared. Now I'm going to send in negative 3y. Negative 3y times 4x squared is negative 12x squared y. Negative 3 times negative 12 is plus 36 xy squared. And then I'm going to have negative 27 y cubed. And the only thing I can combine is this 18xy squared with this 36xy squared. That's going to give me 8x cubed minus 24xy plus 54xy squared minus 12x squared minus 27y cubed. Final answer.
Okay, quick correction to number 5. Yes, this is different color because I had to rewrite it. Did not have the original notes. So on this one, couple mistakes here. 2x times negative 12xy should have been negative 24x squared y, which then is going to join with this negative 12x squared y. Also, not that it's going to matter because it's going to disappear, but when this one dropped down right here, the negative 12x squared y, somehow I lost this y. But that's not going to matter because these two are going to join together now. So that's going bye-bye anyway. And this is going to become negative 12 and negative 24, which is going to be negative 36 x squared y plus 54xy squared minus 27y cubed.
Proving a polynomial identity. Prove that a cubed plus b cubed is a plus b times a squared minus ab plus b squared. So we're going to send the a in and then send the b in. Let's see what we get. So a times a squared is a cubed. A times negative ab is negative a squared b. A times b squared is a b squared. Now we're going to send the b in. B times a is a squared b. I'm keeping the order. B times negative ab is minus a b squared. And b times b squared is b cubed. Well, let's see what we have here. We have a negative a squared b and a positive a squared b. So those cancel. We have an ab squared and a negative ab squared. Those cancel. What are we left with? A cubed plus b cubed. So we prove this to be true. Okay, application. Write the equation for the area of this figure in standard form. Well, here's the formula, 1/2 base times height. Here's your base, and here's your height. So we just fill them in. Area equals 1/2 of 2x plus 10 times 2x minus 5. Now you have two choices here. You can do the 2x plus 10 times the 2x minus 5. That's okay. And then multiply by 1/2. Or you can send the 1/2 into either binomial. I personally am going to start by sending it into this first binomial, only because 2 and 10 are both even. But remember, you only send it into one binomial. So 1/2 of 2 is x, 1x, plus 5, half 10, times 2x minus 5. And now I'm going to multiply. 2x squared, okay, minus 5x. 5 times 2x is plus 10x, and negative 25. Combine like terms, 2x squared plus 5x minus 25. That is the area. So if we know what x is, we can plug that in and get our answer. Last but not least, error analysis. Ernie worked the problem out below. Bert was quick to point out Ernie made an error. Describe and correct the error. Well, this is a very common error I see a lot of. It's just sending this 3 into each of the terms. But technically, this is sort of like number 5 up here. The only difference is minus 7 instead of minus 3. So it's really 2x minus 7 times 2x minus 7 times 2x minus 7, which is going to be way more complicated than what Ernie got. So once again, I'm going to do the hybrid. I'm going to do a shortcut here and get 4x squared. 2x times negative 7 is negative 14x plus 49. All that times 2x minus 7. Now I'm going to send the 2x in and get 8x cubed negative 28x squared plus 98x. Now I'm going to send the negative 7 in. Negative 28x squared positive, sometimes 4 is 28, here there won't 2, 98. Plus 98x, and then minus, see, 9 times 7 is 63, carry the 6, 7 times 4 is 28, 343. Combine like terms, negative 28x squared, negative 28x squared, 98x, 98x. So what we end up with is 8x cubed minus 56x squared plus 196x minus 343. Quite a bit different than 8x cubed minus 343.
Okay, another silly mistake. When I multiplied this, I should have gotten negative 28x, not 14. I forgot to double it. 7 times 2 is 14, doubled is 28. Now that's going to have a double effect here. It's going to make this negative 28, got to double it, into negative 56 x squared. Is also going to turn this 98x into 196x, which is then going to change these two answers to negative 84. Again, join this and this. I'm going to make this into a 4. And then my x's, this plus this, are going to give me 294. So one little mistake and its cascading implications. There you go.
It's not quite a bit different. You still have the first and last term, but basically you end up losing your middle terms by doing the way Ernie did it. There you go.